Thank you so much, Julia. I will just share my screen. Give me a second. So I hope you can see this now. Perfect. So also a warm welcome from my side. I'm really happy to be here and glad to see so many people joining. It's really awesome. First, I also would like to thank Julia and SSC for having me. This is always great to come back to an organization I've been part of some years ago. Cool. So today we're going to talk about 1.5 degrees and degrowth. Is it time for a new pathway to sustainability? And this presentation will focus on two papers I've had the luck to co-author. Those papers are linked below in this slide. If you want to check them out, they're open access. Yes, and now I just going to introduce the steps we're going to go through. So first, I will talk about the paper on 1.5 degrees and degrowth. Yeah, so focusing on climate change and more on the reasons why we should consider degrowth. And I structure this in a background and motivation part, method, what did we actually do, the results, and some summary and implications. In the second step, then, we're going to look at the scientists' warning on affluence, which was actually published before the other paper, but focuses much more on why we can't stop growing, so barriers to change, and also, yeah, what we call systemic growth imperatives, why we can't stop growing, and also much more on the solutions. So how can we get out of this mess? And in the end, we have some time for questions and discussion. Cool. So let's start with the first paper. As you all know, we are in a climate breakdown, which is a highly unequal and unjust process. This is basically shown by those two maps here. On the top map, you see the overshoot emissions of countries beyond their fair share within the planetary boundaries. And those color codes indicate how high the overshoot is. And as you can see, like historically, the overshoot emissions occur mostly in the global north by industrialized countries. Yes, while the global south historically has had very little contribution to that. If we look at the bottom map, we see basically the other way around in terms of the multidimensional climate vulnerability index, which is plotted here. So red means higher vulnerability, and they take into account a variety of factors for this. So those maps basically, yeah, map on top of each other, but rather like in the other way around. So climate breakdown really is a highly unjust process and could be seen as a continuation of historically colonial processes via neocolonialism and, yeah, climate colonialism, really. This is also basically recognized by the IPCC report recent, who said that approximately 3.3 to 3.6 billion people live in contexts that are highly vulnerable to climate change, and they also acknowledged the role of colonialism in this process. So now, what do we do to address climate change? For this process, scientists usually use integrated assessment models, IAMs, to find out like how could we reach those climate targets, such as 1.5 degrees Celsius. And those models, they are hugely complex models with different parts. For instance, they have an economic module, an energy module, a land use module, and also climate module. And as an outcome of those models, you plug in some parametrizations for scenarios, some starting assumptions, and then you arrive at basically what this graph is showing from the IPCC special report on 1.5 degrees. which plots the annual global CO2 emissions projected until 2100. And every line here is one scenario run by those INMs. And the blue lines are the four keystone scenarios of this IPCC special report on 1.5 degrees. And we will talk about them a bit more later. So how do those mainstream established integrated assessment models reach climate targets? We in the paper described this basically through four ways. First of all of them maintain global economic growth measured in gross domestic product. This is especially true for the scenarios that meet 1.5 degrees. For instance, none of the, and this is the case for all 222 scenarios within the IPCC special report on 1.5 degrees. What they also do is they have massive negative emissions. This is the area below the zero line here, marked here, which basically says they suck carbon out of the air and store it somewhere else. And they also rely on huge energy efficiency gains and a very fast expansion of renewables and other energy technology, such as nuclear. We described those sort of factors as indicators later as for feasibility and sustainability risks to the transformation, but we will come to that. This is in contrast a bit to the historical data, which is shown on this graph, which is fairly complex, so I will explain this. We have here three country groups. The first is countries which have seen a recent peak in carbon emissions, which is shown over here, the CO2 reduction rates since the peak years. We have a second group, which is the long-term decline group, which has seen a sort of not so recent peak in carbon emissions. And we have a Eastern European countries group. And here on the left side, you see the CO2 reduction rates since peak years, the distribution of those rates. And on the lower graph, you see the rates from the integrated assessment models, which are necessary to reach 1.5 degrees of warming, 2 degrees, and with different probabilities. And they projected those rates up until the historical data, basically. And what we see here is if we start with the recent peak group, that when did the peak start? It's in around 2008, 2009. And this is where the last big financial crisis happened, after which economic growth rates were very small, which aided those reduction rates. And those rates are still like far away from the 1.5 degree rates. So this aided the reduction. The long-term decline group, we also see the impact of this crisis, but what's standing out much more is that the rates of this long-term decline group, they are even smaller. They are very, very small. So also very far away from what's necessary for 1.5 degrees. And the Eastern European countries as well, we see the impact of the 1990 recession very strongly with the collapse of the Soviet Union, as well as the last financial crisis. So what this basically says is that there is still a strong connection between economic growth and CO2 emissions also in these countries, because this has played a really strong role within the reductions so far achieved, even though they are by far insufficient to achieve the goals we need to achieve. And importantly, these rates don't take into account like global justice considerations, which would result in more ambitious targets for the rich countries in the global north. So what are alternative pathways to the mainstream approach to climate scenarios? This is what we explored in the first paper, the degrowth pathways. And we defined the degrowth scenario through three things, basically. The first one, it's an equitable democratic social transformation to ensure sustainability and well-being for all, which can be described as the value of solidarity, and independent from GDP growth, which can be described as autonomy. This transformation then results in stringent reductions of material and energy use, as well as CO2 emissions, which can be described as the value of sufficiency. And again, this in turn likely results in a reduction in GDP, especially for the richest countries, which is sort of the target area of degrowth. So there are low growth scenarios in the mainstream canon, such as the shared socio-economic pathway 3 and 4. These are specific scenarios of IAMs. However, and I mean, we even see in these scenarios that in rich countries, GDP declines. But globally, there's a growth still. However, these are socially problematic. So what they show is that in those scenarios, there is heightened international conflict, increasing social inequality, etc. So social crisis, basically. And they are also not able to meet the 1.5 target, for instance. The models can't reach the target using this scenario. So all in all, there is no degrowth pathway in all of the 222 scenarios in the IPCC special report. So our research question now was, what are the effects of degrowth pathways on feasibility and sustainability risks of mitigation compared to the current mainstream IAM scenarios? So how did we do that? Our approach consisted in a few steps. So first, we established a set of sustainability and feasibility indicators, which we sort of defined as how high the energy efficiency gains are, or how fast renewable energy needs to expand, or how much negative emissions are necessary. Then we built a very simple top-down model of global energy use, emissions, and GDP. So top-down here means that we sort of take a global aggregate approach and not start from like single technologies and regions and scale this up. So it simplifies the process. Then we approximate the mainstream technology-driven scenarios in the IPCC special report with our model. And then we compare them to our degrowth scenarios using our indicators. So this is just a sneak peek into the model. Basically, you can download this for yourself under the link here. It's just to show you that you don't need to understand all of this. It's just to show you that it's a very simple Excel model, basically, where you plug in some parameters on how crude oil develops, natural gas, etc. And this then leads to final energy demand projections, which then go into primary energy demand, as well as GDP. And from there, we get our CO2 projections. So what did we find out? I'm going to first describe a bit more our indicators, and then we put the picture together and see how our scenarios performed on those indicators. This is, again, an overview of the scenarios we modeled. So the red, orange, bright green, and dark green scenarios are our scenarios. And the light blue and dark blue scenarios here are the ones from the IPCC report. And on the left side, we see the primary energy consumption over time, and on the right, the net CO2 emissions over time. And this is just to show that we roughly meet the range within the IPCC report on those variables. Exactly. And we have different scenario groups. For instance, here there's low energy demand and low energy efficiency gains, or energy GDP decoupling, how we call it. And this is low energy demand, but high energy GDP decoupling. So with high GDP growth, basically. And then medium energy demand, medium decoupling, and high energy demand, medium decoupling. We'll come back to those groups later. So the first indicator for us was energy GDP decoupling. This basically means that if you have an economy that grows, but energy consumption goes down, then you have absolute energy GDP decoupling, so very high energy efficiency gains. However, what we see in the historical data, which is shown on this graph in the points here, is that there's a very tight connection between GDP on the x-axis and primary energy demand. So there's a fairly linear connection. And those colorful lines here, those are scenarios featured in the IPCC report, as well as modeled by the International Energy Agency. And what we see here is that partly, like all of the scenarios, they reduce the linkage between the two, but some completely break it, right? Like they reduce energy demand drastically, but even while increasing GDP. What we basically argue is that this is rather unlikely to happen because there are a lot of systemic rebound effects which are significant, likely, but are mostly ignored in the current models. They are not implemented there. What is a rebound effect? Those are effects which lead to efficiency gains not translating into the actual reduction in energy demand. This can be like very directly the case. For instance, if you buy an electric car, which is much more efficient in driving, so you don't pay as much money to drive it, so you drive more with it. Or you feel better driving it because it's environmentally better, so you drive more with it. Or you invest the saved money into other consumption, such as flight travel, air travel. But those are also much more systemic. For instance, when firms turn efficiency improvements into increased production or increased wages, which then translate into more consumption. So there are a lot of intricate ways this works, and they are mostly not implemented in the model. Secondly, we have the renewable energy transformation. So what we basically argue is a higher speed of this expansion of renewable energy increases the difficulty of the transformation, and also the scale of energy that needs to be replaced by renewable energy is connected to ecological and social impacts, which again strongly affect the global south, because most of the materials come from there. So this is a graph showing the total mineral demand for clean energy technologies in scenarios by the International Energy Agency. So here is 2020 currently in megatons. And on the right side here, we have a net zero by 2050 scenario. And this increases it by 6 times. Yes, so there's a huge material impact here. Thirdly, negative emission technologies. They are high-risk technologies for sustainability and feasibility. And those risks, again, are borne by the most affected and future generations, because currently we only have and afforestation and soil carbon sequestration available at scale. So other technologies are more or less in their infancy. For instance, bioenergy-based negative emission technologies, where you plant, for instance, trees, and then you burn them and store the carbon underground. They have very strong side effects in terms of land use, water use, fertilizer, etc. So again, this is very risky, can compete with food production, etc. And alternative technologies such as direct air capture, which is also developed in Switzerland, they are highly energy and water intensive. Again, this can become very significant if you rely on this to a large scale. So we share the conclusion by Anderson and Peters here, a great paper, that nets are, quote, an unjust and high-stakes gamble, and reliance on them is a moral hazard par excellence. So you should research them, develop them, but don't rely on them to save the day in the end. So if we put all of this together, we arrive at this graph, which is, I think, the key result of our paper. So I will spend a bit more time here. What you see here is basically a scenario map of all the scenarios we have modeled in the different groups I've named before. And we have 3 axes here, basically. One is the mean annual increase of each renewable energy source in exajoule per year, so of solar, wind, and other renewables between 2020 and 2040. And on the x-axis, we have the energy GDP decoupling or energy efficiency increases as the difference between the GDP growth rate and the final energy use growth rate, also between 2020 and 2040. And the bubble size indicates the cumulative CO2 removal until 2100, including carbon capture and storage applied to coal and gas. And what we basically see here is that those scenarios which medium energy demand and medium decoupling, they require very high speeds of renewable energy expansion or like more negative emission technologies. And importantly, here in the lower left-hand corner, these black lines and dots, this is historical data we have plotted. So importantly, those are rolling averages of 10 years. So a single year can be, for instance, here around 2%, but on average, it was much less. Then we have the high energy demand and medium decoupling scenarios, which are less renewable energy intense, but partly even more in negative emissions. And then we have the low energy demand, high decoupling scenarios, which have huge energy efficiency increases. Those are the scenarios which break the connection, but less, again, renewable energy intense. And those blue dots here are scenarios directly taken from the IPCC report, those keystone scenarios. And what we then did was, these are the degrowth scenarios here on the left side. And what this shows is they are much closer to the historical developments as the other scenarios, depending on how much renewable energy and negative emissions you're willing to accept. So this scenario down here, the decent living energy scenario, which we talk about later a bit more, has like really low energy consumption, extremely ambitious. So that's why it's so close to historical data, because it requires very little renewable energy expansion to meet this scenario. But even in this scenario, all human needs could be met. Yes. So this is basically the core message from our paper. Degrowth minimizes those risks, which are assessed here. So we also went further than that and looked at equity considerations. So if we talk about equity, then this is to recognize the historical responsibilities of the global north and especially the most affluent people within the global north, because this increases their mitigation responsibility. So they have emitted the most, so they should reduce quicker than others. Additionally, a consideration of equity calls into question the reliance on large-scale renewable energy transition and negative emissions, because again, those technologies affect the most vulnerable the most, as well as future generations. So again, this is an unjust process as those people are already suffering the most. And this is strengthening the call for degrowth in the global north. This is basically our conclusion of this section. And we also modeled some distribution scenarios. So this is the average per capita final energy consumption, which is spread in the future scenarios over 10 billion people. And this is the historical data for 2017. So you see the global north here has massively higher energy consumption than the global south on average, and this even hides internal differences, which are even higher. And then in our degrowth scenario, this would be massively reduced if we aim for an equal distribution of energy consumption. But even in an aggregate growth scenario, such as the moderate scenario, you end up, if you would distribute it equally, you end up with a massive reduction for the global north. Those lines here, those are the decent living energy scenarios I've mentioned earlier. So where all human needs can be met at this energy use on average globally under different assumptions on demand as well as technology. And what this basically shows is that within our degrowth scenario, all human needs could be met for all people globally for 10 billion people. So then political and economic feasibility. These are big ones, right? Because as Keyßer et al., right, currently abandoning economic growth seems politically impossible. And this is also because in order to achieve degrowth, we would need to decouple well-being from economic growth, not economic growth from environmental impacts, not only at least, and overcome the growth imperatives, which requires deep changes to socioeconomic power structures. So because of that, it's politically more challenging. However, we argue that the state of political feasibility, this can change if we know more, if there's more awareness on alternatives, and with strengthened social movements. So this is no reason to not research those scenarios, right? Because if we don't research them, we don't know about them, they will always seem unlikely. Economic feasibility is usually described as monetary costs of mitigation as a share of GDP. And if you compare sort of the degrowth scenarios, then with the mainstream scenarios, sort of mainstream economists and scientists view them as economically inefficient because they show this loss of GDP as a result of degrowth. And this is compared suboptimal, inefficient, compared to just investing in new technology. However, we argue this is super problematic reasoning, actually, because it presupposes that there is an optimal GDP growth path of which every negative deviation is defined as a cost a priori. The problem here is that who is defining this optimal GDP growth path, whose contributions are included, as well as what effects does this GDP growth have. So we argue this is actually comparing incomparable categories with incommensurable, not comparable welfare implications. So if you build a windmill and create jobs and spend money, increase GDP in the process, use materials, etc., this has very different implications for welfare than, for instance, reducing work times, working less, having less pollution, but also less GDP. Yeah, but those, we argue you can't just put a monetary number on this and then say the one is necessarily better than the other, which means GDP growth can be suboptimal from a welfare point. As an alternative, we argue human needs perspective is much more useful. So people have finite, satiable human needs, and it's like very different how they satisfy those needs. But it remains a question of prioritization, right? Should we expand renewable energy and feed ourselves, or should we keep flying and driving in cities, for instance? This is a question of prioritization. And in principle, research shows that we can have a high quality of life and a fast renewable energy transition, even with declining GDP, if we prioritize those things. So as a summary point, what the paper really says is that degrowth scenarios substantially lower socio-technical risks compared to established scenarios. However, the political challenges are relatively high as we address really powerful groups in society, and there would need to be a lot of social change with adequate resistance, probably. However, those are not reasons to not research degrowth pathways. In fact, they should be as thoroughly explored as our mainstream technology-driven ones, in order not to be biased, really, and to foreclose possibilities which might exist, less harmful than the other ones in many aspects. So here are some examples of papers which already model degrowth in more detail. You are highly recommended to check those out. I won't go into detail now because we don't have the time. But yeah, just for you to look them up, I can really recommend checking those out. Cool. Now we go more into the sociological perspective on what is holding us back actually, and what we can do about it. So I will talk about a little bit what we researched in the paper, but in the end I will also give a bit more my own opinion on this, as it's really a very strong open debate with a lot of different perspectives. So yeah, we can definitely discuss all of that for sure. So why can't we just stop growing? As we all know, like when GDP growth stops, then we have a recession, economists call it, an economic crisis, which causes a lot of social problems, rising unemployment, bankruptcies, financial market crashes, etc. So these are really undesirable consequences which should be avoided, right? Why is this? Because there are growth imperatives in the system, and we follow the definition here by Richters and Simonite, which define it as an exterior condition that makes it necessary for an agent, such as an individual, firm, or state, to increase their economic efforts as to avoid existential consequences. And those economic efforts, those are defined differently if you talk about different actors. For instance, with individuals, they are consumption, or firms, investment above costs, basically, net investments. Cool. As I said, it's a really open research field, lots of debate. So yeah, just for you to know, it's yeah, much more controversial, the area we go into now. Cool. So this is just to show you a overview of what exists as sort of ideas, what could be those growth imperatives. And this is again from Richters and Simonite, and they have already evaluated those ideas along two axes. One, how strong the coercion is this like free will, or is there social coercion behind the growth driver or imperative? And the level again of state, firms, and households. And here, for instance, they look at a matter of taste or fetish ideology as this growth focus, why we are growth addicted. And in the social coercion category, they look at you know, loss of income for individuals if growth stops, or skyrocketing unemployment, or general system stability. Cool. What do we think causes those growth imperatives? What we argue in the paper is that growth imperatives are inherent to capitalism as a historically specific but currently dominant socioeconomic system. So what is capitalism? I think it's really important to clarify that capitalism is a monetary is the system where monetary exchange dominates social reproduction, including labor power, land, and finance. So what this means basically is that everything you need to live, to reproduce your energies, you need to get in exchange for money, which basically means you need to do wage labor in order to earn that money. Then there are work.
Lorenz, sorry, I'm just interrupting because we have a weird sound with your mic.
Oh. Okay, maybe I tune it down a bit. Is this better?
I don't know. It's sometimes it comes, sometimes it.
Okay, I'm sorry. Yeah, apparently also my computer is breathing very heavily, so maybe that's the cause.
Okay, we'll see.
Okay, I'm sorry. Cool. So as a second step, there are workplace hierarchies between workers and capitalists, which are enforced by states. So even though people do not take part in production, they can own the process and then decide how to use the surpluses. Then firms face more or less strong competition. This is just to say that you can also have very oligopolic or monopolistic markets, which could still be capitalist in the sense, because production is motivated by the expectation of profit, which is just revenue above costs, basically. So what we argue is that economic growth is a systemic outcome of these social structures of capitalism, really. How does this look like in more detail? I again structured this around those three concepts, basically. So one, capitalists have a lot of power. They can fire workers, they can depress wages, they can move production and finance to other countries if conditions are bad, and they have the resources to influence politics, media, and culture, etc. Why is this important? Because they also compete with each other. If conditions are bad for profits and growth, then they have no interest in keeping the workers or in keeping wages high. They can just reduce this. This would be, for instance, a bit different in cooperatives where people have an interest in, for instance, reducing working times instead of firing people. Through the competition between firms, firms are basically coerced into minimizing costs, for instance, through economies of scale. So by producing more, you can reduce the unit costs and increase the profit you get from selling each product. So getting bigger in this sense has some advantages here. They are also incentivized to innovate and then advertise it to convince people to buy the new product. So states also face growth imperatives because they are dependent on tax revenues as well as low unemployment. So when the economy slows, unemployment, so there's less investment because profit expectations are low, then people don't get employment, are dependent on social benefits, which really brings states into big trouble. And this is important because also states are in competition with other states, be it militarily, politically, and economically. So it's really detrimental for states to not look at the conditions which foster profit expectations and growth. So as a result of these mechanisms, states empirically strongly foster growth and also cause a lot of economies of scale, for instance, by keeping energy costs low. And in this sense, you could say they behave as a sort of ideal aggregate capitalist. So they mediate conflicts between different groups of capitalists and also between workers. And growth here acts as a huge legitimizer and also pacifier of social conflicts, because everyone can have their cake and eat it too. There's no need to have like strong struggles about who gets what. But also workers and individuals can face growth imperatives, for instance, structural barriers to reduce consumption, e.g. through unsuitable options for employment, that you only have full-time jobs available, for instance, housing, you live in big apartments with little space or gardening space to grow your own food if you would like. And there's also no public transport or very expensive, just available, and car infrastructure is dominant. And also information, you often just don't know, is this sustainable or not? It's very hard to know, or takes a lot of effort to find out at least. Then there's also positional consumption, which we focus a lot, which is a key mechanism of social status competition, especially in capitalism. So how this works is basically people buy goods which signal social status by being rare and expensive. And money again here acts as a sort of entry point to this. So people try to relatively position them better than others by pursuing those goods, which might increase their own well-being, subjective at least, but also decreases the ones from the others. So on aggregate, it's usually a zero-sum game, which with huge social and ecological costs, though. And this is especially pronounced in capitalism because monetary accumulation really seems to have no end. There's always more money to be made, and even like billionaires, they have weird competitions, who has the longest yacht and stuff. It's crazy. So this is one mechanism. Efficiency consumption is another one, because also workers compete against each other in labor markets. So often this drives consumption, because you need to be like efficient in your time management to keep up with others, which often, for instance, makes car ownership necessary, or smartphone ownership, or also like fast food, or dishwashers and washing machines and all those stuff. They just make life easier under stress when you have to perform well. Okay, how do we get out of this? There are many ideas how to do that. You don't need to read this all. It's just to show you that a lot of this exists. This is from the report I showed earlier on a societal transformation scenario by Kuhnhen et al. Also highly recommend checking this out. So for instance, what we could do, I highlighted it here, is we could have a more progressive tax system, a wealth tax and a high inheritance tax, which strongly decrease inequality, redistribution, basically. You could have a reduction in wage labor, working hours, reduce them to 25 to 30 hours a week. Yes, so these are changes which we could pursue, which would make life much easier to alleviate those growth imperatives. Or we could have decentralized renewable energy sources which exist as commons, so which are managed by communities which use them as a commons together. Further, we could satisfy basic human needs such as housing, food, healthcare, and electricity, not traded via markets, but organize their production and distribution democratically, yes, to make them independent from monetary channels, basically. This would also need to go along with economic decision-making and investments being democratized, and also production organized democratically through cooperatives and collectives, for instance. Cool, but how do we get there? And here's where it gets tricky, because there's a lot of conflict, and how can we achieve those changes? And I've structured 3 overarching pathways, which we discuss in the paper, along 2 axes, whether they are compatible with capitalism and what role the state takes in the strategy. So do we need to take state power, for instance, through like parties in a democratic election, or shouldn't this be part of the strategy? First, we have what we term reformism. This is basically that we need value changes within the population, which can be brought about by social movements. And then these value changes will translate into different politicians and parties being elected, which then implement the reforms I've just talked about, like working time reductions or socio-ecological tax system changes. So this is very much focused on using established democratic channels to change things. Then we have what one might call hierarchical economic democracy. You could also call this a form of state socialism, where taking state power is very important, and the sort of also through parliamentary democracy, but the things you implement, the reforms, are likely incompatible with capitalism in order to avoid those catastrophic, chaotic downturns, which are socially unsustainable. So what they propose is having, for instance, stronger state ownership of firms, and also more price regulation, rationing, etc. So like stronger measures to make the degrowth socially sustainable. Then lastly, we have a form of horizontal economic democracy, which you could also call libertarian socialism, or also a form of anarchism, which is also incompatible with capitalism. But this strand focuses much more on sort of building outer parliamentary, horizontal, direct democratic power via organizations which are networked, for instance, like neighborhood assemblies or cooperatives, And those should build up a form of power to pressure the state into reforms, or even completely ignore the state and just do their own thing, which would then translate later into value changes and the reforms being implemented by the state. Cool. So what do we do with this? This is where I bring in a bit my own view, which is also based in part on my master thesis on the Green New Deal. And it's very much work in progress and unpublished. So yeah, keep this in mind. First of all, I think it's really important to recognize that actions must be context and location specific. There's no one-fits-all plan. So what I'm going to sort of say, it's just very rough guidelines and needs to interpret it differently depending on the context. Who is to drive change? I think this is a crucial question. Of course, who's the most likely social actor to do this? Here, I would argue the primary driving force is very likely to be a direct democratic horizontal movement of movements across oppressed groups, for instance, workers, youth, and indigenous people, which are the most the groups which most suffer under those changes, such as climate breakdown. What does horizontal mean? So it means that sort of all power is concentrated at the bottom. So you can have coordination committees, etc., but those are relatively strictly mandated and delegated positions without power to impose stuff on the movement. Then I'm going into a few categories of change. So a categorization of what actions we should do and why. And this is based on Eric Olin Wright's categorization, which you're also free to check out. This is described in the sources I detailed below. So the first category is called alternatives, or what Eric Olin Wright calls interstitial transformation, which is focused really on building alternative institutions and groups on the ground, which develop in the niches of the current system. So what we should do is build horizontal but networked federated counter-institutions such as unions, cooperatives, and neighborhood assemblies, which form a network of mutual support and solidarity. And what those institutions do is they educate and show alternative ways of living through praxis, through living it, that like living a more ecological, degrowthy way of life is actually desirable and possible. I think this is the strongest way of showing what's possible, really. Then, however, we still need reforms or the symbiotic transformation, because as I've shown, like also horizontal movements, individuals, they are limited. They need to work long-hour jobs to come by. They need to, basically there's a lot of struggle involved and few people have the time and resources to engage in this. So for instance, working time reduction or a universal basic income could really help make it easier for those movements. But the key point is, how do we reach those reforms? And there, I would argue that the most reliable way of getting those partly fairly radical reforms is to pressure the state via those institutions and movements, via direct action, to implement reforms which strengthen the movements itself, which devolve power to those institutions. What are direct actions? So it's basically, instead of appealing to others to act for you, you act for yourself, which can incorporate a wide variety of things like occupations, boycotts, but also protests and these sort of things. And strikes, of course. So they have historically shown very effective to achieve those things. And importantly, there's always the risk of cooptation, so that as established institutions try to take power away from the movement and channel those energies into established processes where they can be handled with much more easily. So this results in the need to stay autonomous from and minimize our involvement in institutional politics, although it doesn't mean, of course, that we shouldn't cooperate with sympathetic politicians, for instance, or refrain from voting. I think that's not involved here. but still, like one really needs to think very hard where to invest resources and where you get the biggest bang for the buck. And I would argue here this is not in institutional politics. Then category 3 is the opposition part, the ruptural transformation. And I would argue that this is sort of the connecting element between the alternatives and the reforms. How we get the reforms is that we oppose destructive developments and defend against backlash via direct action and the diversity of tactics. So again, like occupation, strikes, etc., which build our confidence in what we can achieve as collectives, basically. Cool. So the result would be let's get organized. And this is an invitation for tomorrow's climate strike at 5:30 at Helvetiaplatz. I hope to see you there. Cool. So I think this is all from my side. Thank you very much for listening. These are some Twitter handles of Degrowth Switzerland as well, where I'm active. And I would like to extend a huge thanks to Sustainability Week, Nachhaltigkeitswoche Zurich, for funding the article processing charge for the first open access paper, the 1.5 degree one, as our publishing system is completely broken. Yes, so you need to pay a lot of money to get this published for everyone. Cool. That's it. I'm very much looking forward to your questions and the discussion.